Okay, so independent events. So independent means that it's going to happen independently from the other event. So the two events, say we roll a dice and we choose from a deck of cards, those are two different events that have nothing to do with each other. Okay, that's independent. Dependent means that the two events, one of them is going to depend on the other one. So if we have, like yesterday, we had a big old bowl of tickets. So every time we took a ticket out, the total number of tickets decreased, right? So that would be dependent. So the first thing we're going to talk about is the independent. So the probability of two independent events can be found by multiplying the probability of the first event by the probability of the second event. So yesterday we did those probabilities. We're going to do the same thing today, except we're going to do it twice and then multiply those fractions together. Okay? So for independent, we're going to set up two fractions and multiply them together. And simplify.
Yeah.
Okay? Yes.
Miss Buckingham's at the door.
Okay, hold on. What? Okay, so example 1. Two number cubes. What's a number cube?
It's a cube that has a number.
So like a dice. Okay, just a dice. How many sides are on a dice?
6.
6. Why did it pause up there? Oh, there it goes. So there's 6 sides on a dice. So 1 through 6. 1 red and 1 blue are rolled.
We have a few announcements. I'm sorry we're late getting this done.
Okay, so two number cubes or dice, 1 red and 1 blue are rolled. What is the probability that the outcome of the red number cube is even and the outcome of the blue number cube is a 5? So don't be tripped up that they're giving you two different scenarios. We're going to do it one at a time. So remember, our dice has 1 through 6 sides on it. So the probability of the first one that the red cube, number cube is even. So good. It would be for the red 3/6 or 1/2, right? So the red number is even. Okay, so then now ignore the red. We're looking at the blue. The outcome or the probability that the blue number cube will roll a 5. Good. So 1/6. So we did exactly like we did yesterday. We just did it twice with two different events. So now all we have to do is multiply those two numbers together. So 1/2 for the red cube, that was our probability, times 1/6 for the blue cube. Remember, if you're multiplying fractions, you just multiply across. So when we're multiplying, the denominators doesn't matter. We just multiply across. Good. Nope, multiply across. We're just multiplying these fractions. Good. So 1 times 1 is 1, 2 times 6 is 12. So that very bottom, the probability that the two events will occur is 1/12. That's it. So you're doing just like you did yesterday. The only difference is that you're doing it twice, and then you're multiplying those numbers together. So that's independent. So now, dependent, if two events, so A and B, whatever they may be, are dependent, then the probability of both events occurring is the product of the probability of A and the probability of B after A occurs. So like the first part, we did two different fractions. There were two different scenarios going on. They really didn't have anything to do with each other. This time, the second fraction will be affected by whatever happened the first time. So let's do this practice problem so that makes sense to us. So example 2, 6 black socks and 4 white socks are in a drawer. So how many total do we have? 10. So if one sock is taken out without looking, if one sock is taken out without looking and then a second is taken out, what is the probability that they both will be black?
6 over 2.
So, hold on. Just like we did on the first one, we're going to do this one at a time. So, Trey just said it. The very first probability, the first sock is black. There's 6 black socks. There's 10 total. So, Trey was right. 6 over 10. Can we reduce that?
Yes. 3. Yep. 5th.
Good. Okay, so the first probability that the first sock would be black is 3 over 5. So then the probability that the second sock will be black. So hold on. We started with 10, but we took a sock out. So how many socks total are left? 9. So that's going to be my bottom number now. Same thing with the black socks. We had 6, but we said we took one out.
5 over 9.
So there's 5 left. So 5 over 9.
That can't be simple.
And that can't be simplified. So the second time we did it, pulled a black sock, and the probability was 5 over 9. Okay, so then the last question, the probability that we'll have 2 black socks.
And you go down to 8.
So just like we did on the top part with the independent events, we're just going to multiply these two numbers together.
Oh.
So 3 over 5 times 5 over 9.
You could simplify it to 3/15.
Mm-hmm.
Oh.
So 5 times 3 is 15. 5 times 9 is 45.
1/3.
1/3. 3/15, and then you can go down one more time, 1/3. So the probability of choosing 2 black socks is 1/3. So that's what it means by dependent. Your second fraction depends on whatever happens the first time. So our total number decreased and our number of black socks decreased. This will make more sense the more practice we do. So these exercises, a card is drawn from a deck of 10 cards, numbered 1 through 10, and a number cube is rolled. How many sides are on a number cube? 6. So we've got numbers 1 through 6. Determine each probability. So since we're looking at 2 different things, we've got cards and we've got dice, this is an independent event. We're just looking at the 2 separate events. They don't affect each other. So number 1, the probability of pulling a number 10 card, and the 3 on a dice. So do them separately. So look at 10 first. What's the probability of pulling the number 10 card out of that deck? 1 out of 10.
But I don't get how we're getting 1.
Are you dropping it over 6 or 1 over 6?
So, but you're looking at the chance that you'll roll a 3.
So 1 out of 6.
So 1 out of 6.
That's what I said.
Okay, so we've got the probability for your cards. Pulling a 10, the probability of rolling a 3 on your dice. So then multiply those 2 together.
1 over 6.
One's gonna die.
Yes.
A dying dice or something. No, they die.
Yeah, so it should be
That is very important.
die, I think. Number 2, the probability. The probability of 2 even numbers. So the probability of pulling a number card, an even number card, on your deck of 10.
5, 1 half.
4 out of 10.
So for your cards, we've got 2, 4, 6, 8, 10.
Oh yeah, so 5.
So 5 out of 10, or 1 half. Then your die. If you've got 1 through 6, and the even numbers on our die are 2, 4, 6.
1 half.
Good. 3 out of 6, or 1 half. Okay, then last step, just multiply those 2 together. 1 half, good, times 1 half.
gonna be 2
Wait, would
fifths.
you get the same thing?
It'd be 1/4.
It's one multiplied.
1/4, because remember you're multiplying. So 1 times 1 is still just 1. 2 times 2, 4.
We were at 2.
Okay, so number 3, 2 prime numbers. Okay, so remember prime numbers are those numbers that have only 2 factors, 1, and the number itself.
1, 3, 7. 1, 3, 5, 7.
So it should be 2,
No, yeah.
3, 5, and 7.
2's even.
But it only has 2 factors, 2 and 1.
Never known how to do prime. Is it the O?
So 2, 3, 5, and 7. That's all of your prime numbers.
It's 4 over 10 and
Good.
then 3 over 6.
So 4 out of 10 for our cards. Since we have 10 cards, 4 of those numbers are
Then you get
prime.
2/5,
And you can reduce it down to 2/5.
and then you get
Then for our
3 over
die, good, 3 over 6 reduces down to 1/2.
And then you'll get down to 1.
Good. So
1/3 or 1/5?
2/5 times 1/2, 2, that's a 5. 2/5 times 1/2, and then multiply those together. That gives us, Trace said it,
1/5.
2/10, and that reduces to 1/5. Good. Okay, number 4, the probability of landing on a 9 and an odd number.
I forgot the D and and.
No, they did. And
I
N.
was looking at and. Never mind.
Okay, so do the first one. So 9. What's the chances of landing on a 9 on this card?
Number though.
But 9 is talking about the cards.
See, I got confused too.
So 9, the number 9, we're talking about what's the chance of landing on the card number 9 out of those 1 through 10 cards? 1 out of 10. There's only one number 9 card. And then on your dice,
You have 1, 2,
You have-
3 out of
You have 1, 3,
good.
5.
1/2. It'd be 1 over 20.
Good. So 1 over 20 is our chance, our probability of both.
Wait, why do you have to video this? Here's the back.
There's the back. That's dependent. Okay, so number 5, the probability of 2 numbers less than 4 for both. So on your cards, 2 numbers less than 4.
What? Cards have 2, 4, 6, 8.
So what are the numbers less than 4?
2.
Okay, 3, 2, 1. So if we're thinking about our cards, we've got 10 cards. So how many numbers are less than 4 with those cards? We've got 1 through 10,
3 over 10.
3 over 10.
Well, there's actually gazillions. Like a gazillion.
We're looking at, no, 1 through 10 cards. That's what we're looking at right now.
3 over 6.
And then your dice should be 3 over 6,
Dang, everything's just 3 over 6 with the number.
reduced down to 1/2.
Should be 9 over 60. That can be simplified.
It'd be 4 to 40.
Can that reduce?
That can reduce.
So 3/10 times 1/2.
3 doesn't go into 20.
3 over 20. It only goes
It goes
in
into 21.
sometimes.
Good. So 3 over 20 is as small as we can make that fraction. Okay, last one. The probability of 2 numbers greater than 5. So let's list all of the numbers greater than 5.
8, 9, 10.
7, 8, 9, 10.
So now
So for our
5
cards,
over 10
good.
reduces down to
5 over 10 of them
1/2.
are bigger than the number 5. So yeah, that reduces down to be 1/2.
and then 1 over
1
6.
over, yeah.
Perfect. There's only one number greater than 5 on your dice.
1, 12. And that's it.
So then we multiply those 2 probabilities together. 1/2 times 1, 6. 1/12. Good, guys. Well, that's it.